Hello. So we've seen that for the normal distribution, how to use the mean and the standard deviation to figure out certain percentages under the normal distribution curve. We saw that we learned about the 68%, 95%, 99% rule. This says that if you are within one standard deviation away from the mean, that contains 68% of the data of the people or the objects that you're interested in. If you are 2 standard deviations away from the mean, that contains 95% of the data. And if you are 3 standard deviations away from the mean, that contains 99.7% of the data. Let's look at an example. 95% of students at school are between 1.1 meters and 1.7 meters tall. Assuming that this data is normally distributed, you can calculate the mean and the standard deviation. The mean is halfway between 1.1 meters and 1.7 meters because if you look at 95% matches the picture of the standard of the normal distribution curves, that's 2 standard deviations away from the mean. So the mean is going to be halfway between these values, between 1.1% and 1.7%. So if you take the mean, then you get 1.4 meters. So the center of your normal distribution will be at 1.4 meters. Now, as I said, 95% is 2 standard deviation either side of the mean. So 1 standard deviation is going to be, if you subtract, if you find the difference between the top value and the bottom value, 1.7 minus 1.1, and then you divide by 4 because basically there are 4 standard deviations within this region, 2 on each side of the mean, then you get the standard deviation is 0.15 meters. So this is an example of sort of finding information from the percentage. If you know the percentage of something under the normal distribution curve, then you can find the mean and the standard deviation. Now, it's good to know that the standard deviation, because we can say that any value is likely to be within 1 standard deviation, like 68 over 100 will be very likely to be between 2 standard deviation, 95 out of 100 will be, and almost certainly within 3 standard deviation, 997 out of 1,000 data points will be. Now let's look at an example where we can use this information to detect counterfeits. Vending machines can be adjusted to reject coins above and below certain weights. The weights of legal U.S. quarters have a normal distribution with a mean of 5.67 grams and a standard deviation of 0.07 grams. If a vending machine is adjusted to reject quarters that weigh more than 5.81 grams and less than 5.53 grams, what percentage of legal quarters will be rejected by the machine? That's an interesting problem. So let's see how we work this out. A weight of 5.81 is 0.14 grams or 2 standard deviations above the mean. A weight of 5.53 is 0.14 or 2 standard deviations below the mean. Okay, so we found that basically this answer was found by subtracting these given weights from the mean. So if we look at the problem, alright, let me find the problem again. If we look at the problem, it said that the mean was 5.67. So you basically subtract 5.81 minus 5.67 and we get 0.14, which was 2 standard deviation, because 0.14 is 2 times 0.07. And if we subtract 5.67 minus 5.53, again we get a 0.14, which is 2 standard deviations below the mean in that case. So By accepting only quarters within the weight range 5.53 to 5.81, the machine accepts quarters that are within 2 standard deviations of the mean and rejects those that are more than 2 standard deviations from the mean. Okay, so remember from the rule, the 68, 95, 99.7% rule, 95% of the quarters will be accepted and 5% of the quarters will be rejected. Okay, so that's an example of how this normal distribution is useful.